All right, so we are on. So welcome everyone to this session. It's a Q&A session, so it's not the start of the course. So today we will just share the curriculum to see what will be covered in this course. And then we'll take questions, any questions that we might have, and open up for any discussion, any additional points that people might have. Yeah, but before we start, before I hand over to our the course tutor, Rakvi, who is a pure mathematician, actually with research background in elliptic curves, which is the best thing that can happen to a course, is to have some a researcher in the field actually, doing a course to a wider audience on the applied side of things. Because Rakvi is a pure mathematician, which is great because it means that she has the expertise in the field that you can dive and ask her depending on your level of sophistication a lot of mathematical questions that she might be able to help you with or guidance or whatever, especially in the project part of the course. Okay, so before we start, I hand over, I want to just highlight two motivations for this. So the first is that, the mathematics that we'll learn in here, this is the basic stuff that you need to understand elliptic curve cryptography, which, most of you are joining this course because, you know about, the how successful elliptic curve cryptography is basically the bread and butter of, most of the public key cryptography that we have today, right? So understanding the mathematics of it is very, very, very important, especially in terms of, if you want to go and build new protocols, for instance, or even analyzing the existing protocols, for vulnerabilities, it becomes very, very, very important. So in other words, whether you want to do cryptography or crypto analysis, understanding the mathematics is very important. Yeah, and you couldn't be in a better hands than Rakvi. The other thing is, in this quantum formalism community, next year at some point, probably in the summer or something, we plan to have a course series on post-quantum cryptography. In particular, we will focus a lot on isogeny-based cryptography. So that means that, this course with the Rakvi will be the foundation stuff for it, so because isogenies are, special maps between elliptic curves. So you need to understand what elliptic curves are in order to have any chance of understanding, anything to do with the isogenies. Yeah. So this is the motivation, the two motivations for the community members that I wanted to highlight. So yeah, without further ado, maybe I'll hand over to Rakvi. Maybe Rakvi, you can start sharing off a bit about your mathematical background, and then feel free to go ahead with the schedule on sharing what you have in mind for the curriculum and so on. And then anyone, you can just feel free to ask questions. So to myself or to Rakvi or both. Yeah, so I'll stop sharing my slides, and Rakvi, the floor is yours. And thank you for taking on this challenge.
Yeah, again, thank you for giving me this opportunity. Hi, everyone. I'm Rakvi. So I'm currently a postdoc working at the University of Pennsylvania. And I did my PhD from Cornell University. So most of my research has been on focus on elliptic curves and their associated interesting things that we want to study. Like, for example, isogeny is one thing that Bambode already mentioned. So yeah. So, oh, hi. Yeah. Nice. Yeah. I think I remember. Yeah. I couldn't see your face. So but yeah, hi. Yeah, I think we met. Right. So yeah, so I gave a talk at LuCant about some of the joint work that I recently did with one of my co-authors, which is also on elliptic curves and Galois representations and studying interesting properties on them. So this, I can share my syllabus if that's okay, and then we can take on questions. So 1 second.
Let me check. I think you do have permission to share. I will just check. Yeah. Okay. Yeah. I think I need to enable. Sorry for that. Yeah, you should have permission now.
I think, yeah. Can everyone see the PDF?
Yes.
Yeah, it's loading.
Okay.
Yeah.
Awesome. So, yeah, this is a rough outline, and yeah, I'm open to comments and suggestions. So, if anybody wants to tweak this, or if you want to focus on a particular thing, let me know. We can expand or shrink based on whatever is more suitable. So, I'm planning to use this textbook, Guide to Elliptic Curve Cryptography, by Daryl Hankerson, Scott Wonstron, and Alfred Menezes as a book. I chose this book particularly because I was doing some rudimentary research on what to choose, and this is a particularly nice book because it doesn't start from like basic. It assumes some, not huge, but some small amounts of knowledge of elliptic curves, and it mostly discusses on applications, like why do we care about elliptic curves in the context of cryptography, and why do we care about cryptography at all. So this is a good mix of theory and applications, which I think this course is all about. So that's why I chose this book. If anybody has different suggestions, I'm looking forward to it. So let me know. So this is, as you can see, I'm planning like a 10 lecture series. So first lecture, I would like to focus on cryptography, public key cryptography, elliptic curve cryptography. First of all, why do we care about cryptography at all, which Pambode slightly discussed in the introduction, which is a good motivation. And even in cryptography, we have so many systems that don't necessarily use elliptic curves. Why do we care about elliptic curve cryptography? Why is that useful? What are its strengths, its weaknesses? What are the difficulties in implementation? Some of the rough outline. So this would be mostly our first lecture, mostly motivation and going about uh, and discussing something about cryptography. The next couple of lectures, I'm planning to discuss some abstract algebra by giving as many explicit examples that I can. So I want to start with introduction to finite fields. What are those things? Why are they useful? Again, in the context of elliptic curves and cryptography. So there, so fields, right? So fields are interesting because these are the objects where we have basic arithmetic operations. Like you can perform all the four operations on fields: addition, subtraction, multiplication, and divisions. There are certain objects where you have multiplication but you don't necessarily have division, right? A bit which is a bit counterintuitive, but like as mathematicians we do care about these things. So fields are nice in that sense. You have all the, so think of rational numbers, for example. You can add, subtract, multiply, and divide two rational numbers, right? So I want to discuss finite fields. What are those things? Arithmetic operations on it, and with specific example of polynomials, because they are a very rich source of finite fields. So this would, I'm planning to take 2 lectures to discuss this in detail. And then next couple of lectures, I want to introduce elliptic curves. So to introduce elliptic curve, we need a bit of framework of projective spaces, because elliptic curve is basically an equation written out in projective space, right? So that's why we need a bit of framework to get started on elliptic curves. And why do we, so these are just curves at the end of the day, right? Why are they so special? One of the reasons is because unlike any other curve, you can actually add 2 points, add and subtract 2 points, which is, it's very, I mean, it's very c- also counterintuitive, fascinating, interesting. Like, what does it even mean to add like 2 points on curves? Like, a curve is just a figure, right? It's a collection of points. What does it even mean to add and subtract 2 points, right? So this is the reason these curves are interesting. You have an addition law on it, right? So I would discuss explicitly how do you add 2 points, how can you write it down, and then Coblett's curves are a special example of these things. And then from lecture 6 onwards, my plan was to get started on some explicit cryptography in this context. So discrete logarithm problem, what are some known attacks on this, and what are some open problems. And then lecture 8 is about generating random elliptic curves. This is based on chapter 4 of textbook. domain parameters, signature schemes. Again, it's a bit technical stuff, so I would like to keep it as like I would like to give as much context as possible. Again, why do we care? And then as well as discuss some specific things on it. And then last couple of lectures I planned on chapter 5 of textbooks, which is actually bulk of the textbook, on basically what are some implementation issues with some of these crypto systems, so software as well as hardware. Yeah, so this was my rough outline. I think I can stop sharing, or I can keep sharing, and if you have any questions, you can just ask.
Yeah, thank you. That was a great outline, straight to the point, and I'm sure people already have a sense about the stuff that they will, get out of this this course. So does anyone have any questions or any comment?
I was wondering if it's more presentation based, or if there'll be opportunities to say, like, try out a couple problems.
I was trying to keep it interactive, so we can have, like, we can break for problems, review problems and discussion and stuff like that. So yeah. Yep.
Thank you.
Yep.
And on that, I actually encourage, one of the things that I encourage always people, especially the people taking our courses, is to form their own study groups based on their location, for instance, or the availability of the time zone, because then you can try to solve the problems together. Look at each other's solution before going to the tutor to give you the solution. I started this out of my own laziness of doing. I was like, in my past things that I did, I was like, okay, before you ask me to give you the solution, you actually have to prove me that you have actually tried to solve it. And George has done great actually in organizing the study sessions in it online. Maybe George, you want to share a bit about how the study sessions have been going in the past course and the current course.
Oh, yeah, sure. It's very informal in these courses, except we had a topology course. I've been a beginner as well, so I show how I've struggled with a problem or succeeded occasionally, and other people show how far they've gotten on a problem or present their solution. And it's more, I'm just another student in these study sessions, and we try to understand maybe a difficult point in the previous lecture or slide. Sometimes we find typos, and
That can be really annoying though, like to find typos in study material. It's like you're struggling too hard to understand something and realize the mistake was in the source. It's super annoying. But
it also helps clarify. Oh, we understand enough to see that this is
yes,
a typo.
That's correct. Yes.
And Bambude was always very good with presenting points where this would be a step or two omitted in a proof. That would be a slight homework challenge, and then there'd be more difficult challenges, which would be homework problems, but nothing impossible. So
and the
I found it rewarding.
easy to show. It's easy to show.
The infamous easy to show. So I found it very helpful to me to lead these study sessions, and I encourage anybody in different time zones or regions to start their own. It's very informal. We have a Discord that has voice and video, but if you can meet in person, that's even better. A little coffee shop with some sheets of paper.
Yeah, I definitely recommend this peer-to-peer amongst the course takers, and don't feel shy. And as I was saying in one of the sessions, or I've said several times, very often, you can arrive to the same using different methods. Maybe you could be even reinventing a new, finding a new proof or something else. Yeah, so don't feel shy because your proof is different from someone else or the textbook reference. Just feel free to share it. This is how the learning process happens. So yeah,
Also,
I do encourage you.
would like to mention that feel free to send me an email any point of time. If I know the answer, I respond very quickly. Otherwise, I try to maintain this. But I respond very quickly. So yeah, I mean, feel free to email me with any questions you have anytime. So yeah.
One of the things maybe we can ask the audience here, whether, I know George referenced Discord, which is great for the study sessions, but maybe for asynchronous communication where you need latex and these things, I'm not sure if Discord compared to Zulip, for instance, which one would you, most of the audience, prefer? Because sometimes you might want to type some, question or make a point using LaTeX. It's easier. I don't know how.
I think Zulip is easier considering
Yeah.
LaTeX. Zulip is easier considering LaTeX. So
I think so.
In general, I think Zulip is easier. It's more structured. It's easier to find a thread or an earlier discussion. Discord tends to be a bit of a swamp, and once things scroll away, they're hard to find.
Yeah.
I know other people like Discord because it's got flashing icons and game-like features, so it's up to the individual.
Okay, so in that case,
both the Zulip and the Discord have this feature that you can create different channels, and audio or text depending on your preference. And then, but yeah, as Georgie mentioned, it's easier to navigate on Zulip, so it's actually more user friendly in my experience. But yeah, whatever everyone prefers.
Okay. In that case, shall we say then this is the channel then, the communication, the asynchronous communication channel that we should use. The primary, it doesn't mean that people cannot maybe, if they are doing like George was saying, study groups, for example, they can organize themselves on Zulip and go elsewhere, even use Google Meet. So maybe we should use Zulip as the primary channel.
Yeah, that is the one advantage of Discord is voice channels, but the combination works well. But something like Google Meet is probably better because it's got things like whiteboards, I believe, and share screen and so on.
Yeah. And speaking of, yeah, go ahead. Sorry.
So yeah, so if you want to act like you're in a room with a blackboard, if you can bring up a whiteboard and sketch your solution out, it's easier than holding up a sheet of paper to your camera, although that works too. But it's really up to what people want, if people even want a study session. I'm flexible as to what medium we use. I do like the idea of a Zulip channel anyway for any discussions, Q&A, if that's okay with Rakwi.
I'm fine with Zulip. I would prefer Zulip.
Yeah.
Okay, so if on the study session, George, if you guys want to use Google, I could create a study session from our end because we have the Google business thing, so it doesn't cut up. It's not the free Google where it cuts up after 45 minutes, so you can go on. So you just let me know. We have the enterprise thing. Yeah.
No, that would be great, and thank you for your offer.
Yeah.
Then it would just be a matter when the course is underway, what people's schedules are, what my schedule are, when to find a good time.
Yeah, and I'm also happy to create multiple study sessions. So if people have different study session, different schedule, just come to me. I will create the Google Meet for you, so you can, have your meeting there without being limited to the free Google Meet thing, which is, I think, 45 minutes or half an hour or so.
I really like the whiteboard idea. I think it's a good idea. Because I know so I just did the pre-Arizona Winter School, and we had kind of a problem set each week, and we would kind of have a little section where there was each problem, and then we would work on a problem together, and we'd use Miro, which is similar, like a whiteboard type thing, for people to kind of work out problems, and we have like a TA or someone in charge to kind of step through how we'd think about the problem and how we'd solve it, kind of thing.
The main thing I'd like to emphasize about the study session is there's no need to be shy. Everybody is struggling with the material, and you learn from each other. So there should not be this shyness about, oh, I'm going in front of a group, a professor, an expert, which you shouldn't have anyway, but some people might still have that residual from their school days fear.
One thing that I always say to my students is that no question is a stupid question. So you should always ask as many questions as many times as you want. And yeah, because that's only when you learn. Like, passively listening only does so much than you actively engaging with the material, discussing with your peers, actually asking questions. And
Yeah, I mean, particularly in math, I think you really need to fight it. They say this is the definition. I should say why? Why this? Why not that?
exactly.
These are the axioms. Why not other axioms? Question everything.
Yes.
And another thing also I would like to bring to those who are alive now is the start date. So Rakvi and I, we think the 27th, because so this is meant to be every Wednesdays at the same time. And obviously with the holiday period coming in, and also I believe Rakvi will be traveling also in January at some point. So we might have to skip some classes.
Yeah,
but in general,
January first week that I'm attending, so I'll be away till during that week I'll be away.
Okay. So is it best for everyone if we start on the 27th of this month instead of on the 20th? Because with the Christmas coming, everyone traveling. I'm already on the road. I'm going to Brazil. on the 20th at night. So yeah, it will be like. But if you prefer to have it on the 20th, that's also okay. But I think 27 is probably the best. Let me know, everyone, what do you think, George?
That's hard for me to say. That's right, that week between Christmas and New Year's. I'll be away, but I should be able to connect. That's a Wednesday. So I can make it work for myself.
Okay, so in that case, maybe we lock the 27th just to kick start, because it's going to start with the intro anyway. So, and also the recordings for those of you who are obviously having your holiday Christmas thing at home. You can you don't need to attend the live sessions. You can just watch the recording anyway. So yeah, so we lock it for the 27th and the first session.
And of course, I'm assuming that they will be recorded on YouTube for people who can't make the live sessions.
That's right. In fact, I will create the playlist for this and upload this Q&A session there today, later. So yeah, and I will email everybody. And I will set up the Zulip channel as well and invite everyone to that channel. And, feel free then to organize if you want to meet outside Zulip amongst yourselves, feel free to do so. But I think Zulip is a great platform for asynchronous communication because of its smooth integration with the LaTeX compared to Zulip. Does anyone else have anything? Because this meant to be a Q&A, so I guess if you don't have any questions, maybe we can call it early, or anyone else wants to touch anything. One thing I forgot is I know a lot of some of you might want certification. As it stands, I think the best way is actually project completion. So at the end of the course, you do a small project, and it can be individual project based or group based project. I think it's the best way to showcase the stuff that you learned. So yeah. The exact timelines of it will come as we go through the course. As we come towards the end, we can discuss the logistics, how to submit, and those who need some maybe ideas, where they could, for example, work on. For example, we do have a lot of ideas. We can provide out there also for people. So yeah, and for the best projects, maybe my company, I will talk to them, not guaranteed yet. Maybe we can be a bit generous to provide some sort of award or something. Yeah, we'll think about it. Yeah. So yeah, just an extra motivation to for you guys to feel motivated, not just to earn the certificate, but actually to showcase, an application, of your knowledge, in whether creating some, a protocol or improving something, an existing open source project. That will all do. So yeah. Okay. Anyone wants to make any final comment before we go? All right. In that case, maybe I can stop recording if that's the thing. If so people can have a chance, those who don't want to show up on YouTube, which is okay.
Thank you, Bambode and Rakwi, for offering this incredible resource.